trying to explore is to help us identify that an evolutionary approach is really valuable when it comes to innovation and ideas in the cognitive realm. I wanted to explore some existing methodologies and industries that already apply this thinking slightly differently. And you mentioned, Jasravee, that biomimicry is an industry that I reference in the book. And for me, stumbling across the field of biomimicry was actually the trigger for writing the book. As soon as I sort of learned about biomimicry, I sort of felt this is fundamentally what we do with psychology that biomimic architects and designers are doing with the design and technology. So the field of biomimicry really assumes that anything around us that has survived in nature today has undergone 3.8 billion years of research and development. So there's got to be something valuable with the animals, the flora and fauna that surrounds us today. So rather than, again, look to the sky or assume a magic bolt, sort of lightning bolt will come out of our pencil when solving a design or architectural solution, let's first look to nature. And one of the first examples of this, and I reference this in the book, is the development of the Shinkansen 500 speed train, bullet train, that connects Tokyo and Osaka. And many of your listeners will be familiar with maybe the bullet train, but might be less familiar with the process that was undergone in designing it. And the challenge that was faced on the Shinkansen was reducing the speed, or the time that it took to travel between Tokyo and Osaka. And while there are many sort of facets of the train that needed to be explored, one of the fundamental issues actually wasn't speed. They didn't need to increase the speed of the trains. They had experimental carriages that could sort of travel fast enough. And what the issue was sound. And that actually the faster the trains went, the more sound they made. And one of the key problems they faced was actually through tunnels. So the Shinkansen line has a series of tunnels across it, as many train lines do. We might sort of identify this as an environmental constraint, if we think of it in evolutionary theory. And as the trains sort of bulleted through, they created these tunnel booms, these loud shotgun sounds that was louder than the regulation in Japan. So rather than, again, look at sort of hardcore physics and see how they might explore this, the team actually looked to birds. How can we learn from birds and apply this to the bullet train? And the key inspiration for addressing the tunnel booms was the kingfisher bird, a bird that's perfectly evolved to dive from the air into water to skewer its prey, a substance that is 800 times denser. If it can go from the air to water, maybe it can go from the land through the tunnel without making such a splash. And by adapting the shape of the kingfisher bill, they were able to address the tunnel boom challenge. And this is just a wonderful example of borrowing from nature to solve what is a distinctively human problem. And the field of biomimicry continues to evolve and adapt and apply this thinking, whether that's learning from the ears of hares to develop air cooling systems, learning from the proboscis of mosquitoes to develop painless needles. There's a wonderful business in North America that has adapted from the shape of a humpback whale to create more efficient wind turbines. So it's, again, don't start from scratch. Let's borrow from nature, because if it's around today, there's got to be something good about it. So there are evolutionary principles in biomimicry. And that was sort of the first building block, I think, of evolutionary ideas, that we can steal from nature and apply it in distinctively human problems.